Hey, in this video we'll continue the discussion on access specifiers. In the previous video we talked about the public access specifier, and in this video we are going to discuss the private and protected access specifiers. Remember that the access specifier is going to determine member access in the derived class, and the access specifier can be public, private, or protected. We talked about the public access specifier, which models an is-a relationship, and public members inherited from the base class stay public in the derived class. And with private and protected derivation, those access specifiers do not model an is-a relationship. Private and protected specifiers are used when you want to take advantage of existing code from the parent class, but are not interested in the relationship between the classes. The class will basically still have the members, but it is not an is-a relationship. It's more like a has-a relationship. I've prepared this table for you for your notes. Hopefully this will make it easier for you to find what the access control is going to be in the derived class. Again, in C++ we have many options that you don't always have in other languages, but it can get a bit confusing. But you'll see it's quite logical, it's not that difficult. Okay, for the rows we have what the access specifier is going to be, so what the inheritance or the derivation is going to be, public derivation, protected derivation, and private derivation. For the columns we have what the access is going to be for the members in the base class. Again, whether those members in the base class are public, protected, or private. I put private in the last column to the right, so that those are basically out of the way and those are going to be all the same. Private members in the base class are all going to be inaccessible in the derived class, regardless of the derivation, so whether you do public, private, or protected derivation. Now it's important to note that that does not mean that the members are not there. Alright, you do inherit those members still, but they are simply inaccessible to the member functions of the derived class. And of course they can also not be accessed from outside code, from an instance of the derived class. Let's move back to that first column where we have public members in the base class and we want to do public derivation or public inheritance, right? We want to publicly derive from the base class. Well, in that case, the public members in the base class are going to be public in the derived class as well. Okay, as we discussed in the previous video. And if you do protected derivation, then the public members in the base class are going to be protected in the derived class. Okay, so the access control is basically going to change from public to protected in the derived class. And finally, with private derivation, the public members in the base class are going to become private in the derived class. Okay, so that derivation or inheritance access specifier is going to modify the access in the derived class. Next, with public derivation, let's have protected members in the base class. Of course, those are going to be protected in the derived class. Then if you do protected derivation and you have protected members in the base class, then those members are going to be protected in the derived class as well. Then if you do private derivation and you have protected members in the base class, then those members are going to be private in the derived class. Finally, whether you do public, protected, or private derivation from the base class and you have private members in the base class, those private members are going to be inaccessible in the derived class. Okay, as I discussed before. So I hope this table is useful to you. Okay, a quick example in Visual Studio. I have a base class and a derived class as well, which publicly derives from base class. In the base class, in the public section, I have int x, which is initialized to 1. In the protected section, I have int y, which is initialized to 2. And in the private section, I have int z, which is initialized to 3. In the derived class, which again publicly derives from the base class, in the public section I have this void function toString, just like in the previous video, and this time it's going to print out, so it's going to do cout x and cout y. And if you try and do cout z, of course you'll get an error, because the private members are inaccessible to the derived class. Okay, in main I construct base, which is of type base class, and derived, which is of type derived class. If I do cout and I do base and the dot operator, then we can see the members that we have access to, such as x for example. So you can do x. Okay, so this will work fine. But if you try and do y, you'll get an error that is inaccessible. And the same with z. Alright, so we are familiar with this already. The only members that are accessible to outside code are public members. Protected and private are similar, as I mentioned in the previous video, in that they are hidden from outside code. The main difference again is that protected members are accessible to derived classes, as you can see here with y. So we can do base.x, but base.y and base.z will give us an error. Now with derived we have toString, which is in the public section, and we also have x. So we can do derived.x, and the reason is that we do public derivation, so we do public inheritance. Alright, the derived class publicly derives from the base class. And what does that mean if we think back to the table? Well, that means the public member is going to stay public in the derived class, and the protected member is going to stay protected in the derived class, but the private member is going to be inaccessible in the derived class. So that is why we can do derived.x, because it is public in the derived class, but we can also not do .y, alright, and also not .z, because z is not even accessible to begin with in the derived class. I'll do derived.x again, so that will work fine, and let's just build and run this to see what it prints out. It prints out 1, 1, and 2. So here it will print out 1, and here I do derived.toString, so it will print out 1 and 2. Let's change the derivation here to protected. So this derived class now has a protected derivation from the base class. Think for a second what's going to happen now when we try and access these outside, from outside code in main, using the dot operator. Okay, so if you look at the table again, we do protected derivation, and if we have public members in the base class, then those are going to be protected in the derived class. And also with protected derivation, the protected members in the base class are going to be protected in the derived class. And of course your private members are still going to be inaccessible. They are always inaccessible regardless of the derivation. Okay, so what this means is if I scroll down to main, you can see that we can no longer do console output derived.x. We can do base.x. But if you want to do derived.x, remember that this x now is now going to be protected. So it's public in the base class, but because we do protected derivation or protected inheritance, that public member x is now going to be protected in the derived class. So that does mean that we still have access to it right here in the member functions of the derived class. So we can still do console output x, console output y in the toString function, in the toString member function of that derived class. Okay, so the derived class still has access to those members, but x and y are now both protected in the derived class. And of course, since they are not public, that means they are not accessible from outside code. Okay, let's change this again to private. And now both the public and protected members that you inherit from the base class are going to become private in the derived class. So x and y are now both private in the derived class. We still have access to them, but of course we cannot do derived.x or derived.y in this console output statement. Comment this line out. Build and run, you'll see this will still work. Whether we do protected or private derivation, this will still work. We still do not have access to this right here z, because z is private in the base class. Okay, so whether you do public, protected or private derivation, z is going to be inaccessible in the derived class. Okay, looking at the table again, we do private derivation. So the public members in the base class are going to be private in the derived class, and the protected members in the base class are also going to become private in the derived class. Okay, I'll place a breakpoint down here somewhere, maybe next to this line, derived.toString, and I'll run the local Windows debugger. Okay, I have my locals windows to the right here, and you can see we have these two objects, base and derived. I can click this to expand, and then we can see the members, so x, y, and z. And for derived, if I click that, you will see we get the base class. That is basically part of the derived class. We expand that and we see x, y, and z. I'll just right click on this and turn off hexadecimal display, so we can see the actual values of those integers in decimal. We have 1, 2, and 3 for x, y, and z. You might be thinking, wait, z is inaccessible in the derived class. Well, that doesn't matter, it still is part of the derived class. We just don't have access to it. So right here we don't have access to it, regardless of the derivation. And that's why I mentioned previously that just because the member is inaccessible in a derived class does not mean it is not there. Okay, it is still there. We simply cannot use it in the derived class, in its member functions and so on. and it could be used in some other way in the base class. But there's often a reason why a programmer may not want to make a helper function or something like that available to a derived class. Sometimes it's simply not necessary for you to make something protected or public. You know, some helper function maybe that helps with the construction of the base class, or that has some other functionality. Okay, and in that case you'd make it private in the base class. But as you can see, it's right here. Z is right here and the value is 3 in the derived class, and that is part of the base class. Okay, let's do something else here. I'll go and copy the derived class, paste it down here. I'll just name it child derived class, so it's a child of the derived class or something like that. And I'll set this to publicly derived from the derived class. And you'll notice if I scroll down, X and Y are now inaccessible in the child of the derived class. And why is that? That is because we do private derivation in the derived class. Okay, so it privately derives from the base class. So that means the public and protected members right here are now private in the derived class, and that means the members will be inaccessible in the child of the derived class. If we do protected derivation or public derivation, okay, here we do public derivation and the derived class is protected right now. So that means X and Y in the derived class is protected, and that means that they'll also be protected right here in the child of the derived class. If we do public right here, so the derived class publicly derives from the base class, and here the child of the derived class publicly derives from the derived class, then of course X is going to be public, it's going to keep that access, and then Y is going to be protected. You can see we can do something like this, child of derived.x. It works fine, it prints out 1. If you try and do Y, you'll get an error that it is protected now. But if you change this here to a protected, then X and Y will be protected in the child of the derived class. So we cannot do child.x right here. And if we do private, as I mentioned, then X and Y will be inaccessible in the child of the derived class. You can build and run and you can see that you'll get an error. I hope this video makes it easier for you to understand the difference between public protected and private derivation or inheritance.